In section 7.2, we talked about confidence intervals for proportions. And now in section 7.3 and 7.4, which really go together, we're going to talk about confidence intervals for the mean. Okay, so a population's confidence interval is built around what's called a point estimate. This is any confidence interval, not just the one for the mean. And we talked about point estimates for the proportion. They were the proportion from the sample. So for a population mean, this should be no surprise, we use the sample's mean, which remember we call x bar. And our interval goes from x bar minus our margin of error, which we call E, up to x bar plus E. So just like we were doing for proportions, except now we'll be using a mean. And the formula for the margin of error, if we know the population standard deviation. So if you know the whole population standard deviation, the formula for the margin of error is the z alpha over 2 value, which are the same values that we had in section 7.2. Those don't change. And then the population standard deviation sigma over the square root of n. Okay, so example 1 says, what is the average credit rating? So it says find a 90% confidence interval for the mean or the average FICO credit rating scores of adults applying for credit cards. And we call this sigma over square root of n sigma x bar, like we did in chapter 6. So the sample information, it says we collected a simple random sample of 70 adults who are applying for a credit card. The mean rating of these 70 adults was 688, so that's our mu of x bar. And the standard deviation of the entire population is 68. Now the sigma x bar, that's our sigma over the square root of n, so we're going to take 68 over the square root of 70, which gives us 8.13. So the point estimate for our sample is the mean of the sample, so that's 688. Now to find our margin of error, remember we do z alpha over 2 times sigma over the square root of n. So z alpha over 2, remember we wanted a 90% level. So our z alpha over 2 for 90% is 1.645. And then we do 68 over the square root of 70. And if you multiply that out, you get 13.37. So now if we want to find our interval, we would take 688 minus 13.37, which gives us 674.63, and 688 plus 13.37, which would give us 701.37. So we could say we are 90% confident that the mean or average credit rating of a credit card applicant is between 674.63 and 701.37. Okay, or another thing we could say, just the other way of saying it, is that we are 90% confident that the average credit rating of credit card applicants is 688, our point estimate, with a margin of error of plus or minus 13.37. Okay, so you're really just using this simple formula to find the margin of error and then adding and subtracting it from your mean, your sample mean. Okay, however, there's a problem. In the real world, if we are trying to figure out the mean, it's unlikely that we already know the population's standard deviation. And we were assuming that for the previous problem. Okay, and that was really this, if you want to know about the book sections, that was section 7.3. Now, in section 7.4, we don't know the population's standard deviation. So you might just say, well, just use the sample standard deviation. But it's not as reliable. So is it as reliable? No. So to account for this less reliable variable, we must make a bigger interval than we would have if we had known the standard deviation. So now we're not going to be able to use the z alpha over 2 values. We're going to have new values called t values. So there's another kind of critical value that comes from the t distribution. So we use the t distribution when we don't know the population's standard deviation. Okay. So to find the margin of error, we're still going to use the point estimate of the mean. To find the new margin of error, we do T alpha over 2 times the sample standard deviation over the square root of n. So we're using it. We just have to also use this T alpha over 2 value. Now, to get these values, we use a table from the book. It's table A3, and there's two things we need to know. We need to know our alpha and the degrees of freedom. Now, the degrees of freedom is always equal to your n value, how many you have in your sample, minus 1. Okay, so that's just a rule you'll want to remember. Okay, so now we'll put this into practice. So example 2 says, we want to find the mean length of men's forearms, so from their elbow to their fingertip, with 99% confidence. So this might be used to make shirts that would fit most men. So here's our sample information. It says we measured 32 men's forearms. The sample mean was 14.5 inches, and the sample standard deviation was 0.7 inches. So n here is the sample size. They measured 32 men. So degrees of freedom, we take 32 minus 1, we get 31. Okay, now since we want a 99% confidence level, that means our alpha is 0.01. So on chart, and we want this in two tails. So you're going to look for, there's 2 rows up at the top of this chart. You're going to look at 0.01 in 2 tails. And we're going to go down to 31 degrees of freedom. And the t value we get is 2.744 from that chart. So the margin of error, we do the t alpha over 2, 2.744 times s, the standard deviation, which was 0.7, over the square root of n was 32. Okay, and if we multiply that out, we get 0.34. So that's our e value. So now if we want to find our confidence interval, we take the mean. Remember, our mean was 14.5, it was given. So we take 14.5 minus 0.34, which gives us 14.16. We take 14.5 plus 0.34, which gives us 14.84. So that's our confidence interval. So again, there are 2 ways we can write this. We can say we are 99% confident that the mean length of men's forearms is between 14.16 inches and 14.84 inches. And the other way we could write that is we are 99% confident that the mean length of men's forearms is 14.5 inches with a margin of error of plus or minus 0.34 inches. Okay, so we'll do another example. Example number 3. We want to know what's the average pulse rate of statistics students on the first day of class. So our sample information, we've got the pulse rates of 15 students. Okay, so our point estimate, we want to find the mean. So this is good practice. Remember, you put them into L1 and do stat, one variable stat. If you take the mean of these 15 students, we get the sample mean is 87.87. And the sample standard deviation, remember on your calculator, that'll be SX, is 16.13. Okay, now confidence level, you'll be given this normally in a problem, but let's just say we want a 99% confidence level. Okay, now, do we need to use Z alpha over 2 or T alpha over 2? Now, since we don't know the standard deviation of all people, okay, of everyone in the stats class, just these random students, we have to use T alpha over 2. In our degrees of freedom, we take n, which is 15, minus 1, so our degrees of freedom are 14. So we're going to let, our alpha is 0.01 and 2 tails, and our degrees of freedom is 14. So when you look this up on table A3, we get 2.977. Okay, and the margin of error, we take the t-value, 2.977, times the standard deviation of the sample, 16.13, over the square root of n, which was 15. When you multiply that out, we get 12.40. Okay, so for our pulse rate, remember our mean was 87.87, so we're going to subtract our margin of error, 12.40, okay, which we get 75.47, and we're going to take 87.87 plus 12.40, and we get 100.27. So we can say we are 99% confident that the mean pulse rate of all statistics students on the first day of class is between 75.47 and 100.27. Okay, and of course the other way we can say this is that we are 99% confident that the mean pulse rate of all statistics students on the first day of class is 87.87 with a margin of error of plus or minus 12.40. Okay, now just like we did in section 7.2, sometimes we want to find the minimum sample size. And for these, we only do this when we happen to know the standard deviation of the population. But our sample size formula is n equals z alpha over 2 times sigma over e, that whole thing squared. Okay, so the problem says we want to estimate, with a confidence interval, the average IQ of all stat students, which is clearly higher than 100. So that's just being funny saying stat students are really smart. So planning ahead, we want our confidence interval to have a margin of error of plus or minus 5 IQ points. So that's going to be our E. Is going to be 5. And a confidence level of 99%. So that means our Z alpha over 2 is going to be 2.575. Now, remember from previous sections when we had IQ scores, we always knew for the whole population the mean was 100 and the standard deviation was 15. So we'll use that for this problem. Okay, so we need a random sample of statistics students. We want to know what's the minimum number of students we would have to sample. So remember the formula for this, we take Z alpha over 2 times sigma over E squared. So from what we just talked about, we're going to do 2.575 times 15 over 5, and that whole thing squared. And when you put that into your calculator or do it, we get 59.67. And just like we talked about in 7.2, if you need to sample a minimum of 59.67 people, you can't just sample 0.67 of a person, so you actually have to round up, and we need to survey at least 60 stat students.